Who of you guys are Android developers? Okay, so I'm here to give you a little bit of love because we have a lot of iOS thingies, so we are going to talk about interesting things, really hardcore things. So yeah, this is my presentation, Engineering Wunderlist for Android. But by the way, if you are iOS developer or Windows developer, you are also welcome here because we are going to talk about architecture at the end. So it's not just for Android. I have like 3 parts, and the first 2 parts they are focusing architecture, and then the last one is a little bit of Android. But yeah, so let's go. Who is this guy? Who am I? I'm Cesar Valiente. I'm Android engineer at Wunderlist at Microsoft. We were acquired in June, so before we were a small startup based in Berlin, and then we were acquired by Microsoft because we were like the piece that they wanted to have with Sunrise, with Accompli, so it was Wunderlist, and now we are there. And also Android Google Developer Expert, GDE, that is a recognition given by Google to those who show his expertise, help to grow and improve the community. So yeah, those are my social links, so feel free to add me. I'm always respond, and actually pretty fast, so yeah, feel free. So yeah, we are going to start with a little bit story. Who of you guys knows Wunderlist or have used Wunderlist? Okay. So for those of doesn't know Wunderlist, Wunderlist is a productivity app. Probably is the most important productivity app in the stores, not just in the Google Play Store, also in the iOS, in the Apple Store, for Windows also. So it's a productivity app. It's based in lists and it's based in tasks. So you can create lists, you can create tasks for those lists, you can share your list with your friends, with your coworkers, you can add due dates to the task, you can split the task in different subtasks, you can do a lot of different things. So Wunderlist 2. Wunderlist 2, we released Wunderlist 2 in December 2012. Was a high success, and the main important thing for Wunderlist 2 was that for first time was a native app. Before, Wunderlist 1 was a hybrid app, I think was made in Titanium. So then the team, the owners, the founders of the company, they wanted to create a really native app for so then the users enjoy a much better user experience. So then Wunderlist 2 was a native for all platforms, and this is the Android one. So it was a very nice and good app. It had a monolithic structure. What I want to say with that is was just a module, a project module. Of course, was divided between different packages, but at the end was just a module, so it was highly coupled between the different layers of the architecture. The way to sync was using a batch. So imagine that you have a shared list with or you are editing, you are complete a task, and you are also adding a subtask to the task. Then we were sending these deltas to the backend in a batch way. So then we send all this data, and then we have all this data back, so we could update the UI and our database and so on. And also was difficult to test because it was highly coupled. Of course, we had some tests, but at the end was not a really 100% or with a high test coverage. No. And then Wunderlist 3 comes. We released Wunderlist 3 last summer, and it had a completely redesign in terms of UI and UX. In terms of code, not like UI and UX, because we had to deal with the legacy code, as always, because we are software engineers. So actually, the good thing, I think, of being a software engineer is dealing with legacy code, refactoring thing. Because if not, starting apps from the scratch, yeah, it's easy peasy. So we divide the app into modules, into layers, to separate much better the app into different, the main important things of the app. So this app is highly coupled. It's the app that we actually have in production in the different stores. The most important feature when we released Wunderlist 3 was that real-time synchronization. So we have real-time. So imagine that you have a list shared with your coworkers, and your coworker create a new task, and then you are going to have this new task immediately. So it's coming in real time. It's easy to maintain, to test, and to adapt because it's divided into different layers. So the business logic is in one part, the network thing is another one, and the most important thing also is easy to understand. So for a guy that is coming new to the team, by the way, we are hiring. It's easy to understand, more or less easy. This is a parental advisory. This is what I wanted also to say. So if you are iOS developer, Windows developer, stay here. We are going to talk about architecture. Layers. So Wunderlist 3 is divided into 3 different layers. We have the Android layer, that is the presentation layer. That is, it has UI and Android stuff. It's an Android project. Then we have the Sync layer, that is a Java project, so it doesn't have Android dependencies, so it's a pure Java module. Here we have all our mechanisms to sync, so it's the core of the app, okay? Or the core of Wunderlist. Then we have the data layer, that is also a Java project, so it doesn't have any Android dependency, it's pure Java project, so you could use this module in a Swing app, and it could work perfectly like it's working with Android. And this SDK layer is accessing to the API, to the data. Between them, between the Android layer or presentation layer and Sync and SDK, we have the boundaries. The boundaries at the end, they are interfaces. So the Sync boundaries is an interface that the Sync layer is exposing to the world. So then the Android layer, the presentation layer, can implement that and send to the past to the Sync layer, so the Sync layer can talk with the guy that has implemented his interface. The same happens with the SDK boundaries. At the end is an interface that the SDK is exposing to the world, and the Sync layer is implementing to communicate, to talk with the SDK layer. Why these ways to communicate? We have a dependency rule. We have presentation, we have the Sync layer, and we have the SDK layer. As you see, here are the different circles. So in the middle is the SDK. It's not because it's the main point or the most important thing of the app. It's not that. It's like the SDK is like a standalone entity. So the SDK doesn't know anything about the outer world. The Sync layer, in the other part, can talk with the SDK. The Sync layer can see the SDK. But the SDK layer cannot talk with the Sync layer. The same happens with the presentation layer. The presentation layer knows the Sync layer, but doesn't know anything about the SDK. But the Sync layer doesn't know anything about the presentation layer. So it's kind of abstraction. So the dependency rule at the end is this one. As I said, the outer model knows the inner, but not vice versa. This is a layer architecture, and interfaces are the key. So now we are going to talk about the different parts of the app, so about the different 3 layers. You are going to see down to the bottom right a small semicircle, and it's like it's saying where are we are in which part are we in the layers. No? So the first one we are going to see a semicircle that is blue, that belongs to the SDK. So the SDK, this one. We have 2 important things here in the SDK. We have the network, and we have the WebSocket. The WebSocket is the protocol that we use. We use an implementation of the WebSocket protocol that is our way to have real-time in Wunderlist. Then we have, this is the main way to sync. So if everything is fine, then we are going to use the WebSocket. We are going to have real-time in all our apps. If something happens, the WebSocket maybe is not available, then we are going to go to our REST implementation, and then Wunderlist becomes like a normal app, requesting things to a normal API. Then we have services that they are just an implementation of the calls to the different endpoints. And then in the API model, we have API data models, serializers and deserializers. API models, they are a mirror of the API models that we have in the backend. Then we have serializer and deserializer that they serialize and deserialize the API model. The response that is coming from the server to this API data model. And then we have interfaces, callbacks. The interface is the one that I said before that is exposing the SDK. But for the SDK, at the end, they are callbacks. So it's going to use these callbacks to communicate with the guy that has implemented this interface. And then we have here a sync and a sync test. We were using JUnit, Mockito, and so on. So how WebSocket works and how Wunderlist works at the end. So we have here the client and the server. So the client, at the end, WebSocket is the WebSocket is a full duplex protocol, so it behaves like that. So the client requests a setup to the WebSocket connection to have a connection to communicate with the server, and then the server responds accepting the request. So this is the initial handshake. And then, starting here, the client can send requests, can send data to the server, but also the server can send data, can send the responses that the client was requesting, but also can send data even if the client didn't request anything. So this is the bidirectional flow of packet. And then, because it's full duplex, it's bidirectional, then both can close the connection at some point, the client or the server. This is a small video of it's less than 1 minute, where I'm going to show you an Android app, an iPad. We are going to mark tasks as complete, and you are going to see how the real-time works, how the other, we are going to mark a task as complete in one device, and in the other is going to have a mutation, what we call a mutation, that at the end is a data that is coming from the server, but we didn't request. Well, it has music. So you see here, we mark a task as complete, then we have here the mutation, this is coming for the, through the WebSocket. We mark a task, then in Android it's the same, it's happening. And so on, and yeah. So this is real time, this is Wunderlist, working with WebSocket and the real time. Then we are going to go to the sync layer, that is our business logic. So here we have data models, we have the serializers from the basic model that we have in the SDK. We have cache, we have services that manage this data, they are like the glue between the presentation layer and the SDK. And then we have the sync logic that is called, we follow the Matryoshka algorithm. Well, I think you are the inventors of this. And a conflict resolver that is included in Matryoshka. So for cache, we have cache for different models. We have cache for almost, I think, everything. For tasks, for lists, for membership, and so on. But the good thing of using in our cache implementation is that we have an interface, a common interface that both the database and the cache, they are implemented. So for the guy that is the module that is using the database and the cache to inserting data or retrieving data is kind of agnostic. So it doesn't know if it's accessing to the database or if it's accessing to the cache. It works like that. So we have this common interface, and then we have here the database and the cache implement the same interface, and then we have here the storage manager that is going to receive some implementations using dependency injection. And then for the store manager, when he puts something, doesn't know if it's the database or if the cache, because what he's receiving is at the end is an implementation of one interface. So this is pretty good, because imagine that right now, for instance, we are using SQLite database. But imagine in the future we want to change this database for Realm. It will be super easy. We could just change the module, implement the same interface, and for this guy and this guy will be the same. So using interfaces, I think, is the key. Services. They are used to communicate the Android layer with the SDK. So this is a small example of a task service that is going to retrieve something from the backend. So we instantiate the task service. We send the client that this implementation is it has the WebSocket, it has the REST thingy. So we create that, and then here we have the get complete task. That this function is going to be invoked by the presentation layer. So when the presentation layer wants the complete task, is going to call this function, sending the list and sending this sync callback. This sync callback is the interface that the sync layer is exposing to the world. So the presentation layer is implementing this interface, sending to the sync layer, and the sync layer will use this interface to communicate with the guy that implemented this interface, that was the presentation layer. And here we have response callback, that is the interface that the SDK is exposing to the world. So at the end, we have a service that we call the get complete task. This service is in the SDK, and then we send the list ID and the response callback that we are going to implement here, the typical and success. Then when we have the response, we do something with the response, we check to avoid memory leaks and so on, and then we call the U callback, and this callback, remember, that was sending by the presentation layer, so then the presentation layer is going to update its UI. And then here we have also the failure. Matryoshka. This is a mechanism to properly sync our entire model. We follow this simile of Matryoshkas, right? So we open the door, then we have another one, we open this second door, we have until the end, until we reach a base case. We reach a base case, and at the end, base cases, remember when we were in the university, when we reach base cases, it's because we are using recursivity, right? Recursion. So at the end, Matryoshka is a recursive algorithm. So all our models, they are revision-based. So like a control version system, like Git, like Mercurial, all objects there, they have a revision. They have a revision ID. So every time when a child is updated the revision, when a child updates the revision changes the whole tree up. So in Wunderlist, we have a tree of different objects. Is the root, that is the father of everything, no? It's like God. And then we have a list, and then list has task, and then task has subtask. Imagine that I change a subtask. I mark a subtask as complete. Then I'm going to change the revision ID of this subtask. But also, the revision ID of the task is going to change. And also, the revision ID of the list ID is going to change. And also, the root. So then, it's really easy. Imagine that you are offline 2 days. Then it's really easy. When you get online, you just compare the root. You try to you download the root of the root ID, the revision ID, the root revision ID of the backend, and then you are going to start comparing opening the Matryoshka, right, until you reach the base case, and then you are updating the whole tree. And now we go to the last layer, that is the Android layer, the presentation layer. That this is the only pure Android thingy. So we have here UI, and Android lives and code. So this is like, we could say that is the pure Android module, like a pure Android app, no? We try to maximize decoupling among UI and business logic. So we try that our activities, they don't have a lot of business logic there, because at the end it's bad. But sometimes we have, because at the end, always with the lines, blah, blah, blah. And then we have also the database that sadly is located here. At the end, we put here because we are using SQLite, and SQLite is an Android dependencies inside of the SDK. We could also move to another module. We didn't do it. We will do in the future, in the near future, but right now it's located there. So 2 things that we do. For communicate, I mean, this is not like thing that we are doing always, but I wanted to show you some things that we do from sometimes when we require that. So we have used Event Bus, that is an implementation of the publish subscriber pattern. And then imagine that here at the end is based in subscription and receive data, no? So imagine that we have the activity that is listening for tasks, for changes in the task. And then we have the fragment B that we mark a task as complete. Then we are going to when we mark a task as complete, we put the change there in the bus. And then the activity of fragment A is going to realize that is something new, and then we'll update its UI. And then we have also another example using Event Bus is like code. Imagine that we have a mutation. We have a data that is coming from our server, but we didn't request that. So we are going to receive this data. We are going to take this data from the SDK to the scene, and then to the presentation layer. And then we can put this data to the Event Bus, and then because this guy was listening for this data, was subscribed to this data, is going to take the data and update his model. Sometimes we have a lot of ways to retrieve local data. This is one of those. We use loaders. So we use loader like in a normal way, like this. So to retrieve local data from the cache or the database. So the activity of fragment invoke the loader, then the loader is going to retrieve the data, and is going to put the data into the activity of fragment. And then another case using loaders is the same example as before. We have an event or data that is fired, then we put this data in the bus, and then the loaders also can subscribe to this listening for changes, for data that is interested. So if this screen is open, then the loader is subscribed to this data, is going to realize that this data that is interested, and then is going to retrieve the data from the database and update the activity. So this is mainly, and the time is so-so. This is mainly what we have right now in Wunderlist, but in the last months we are working in a big refactor of the app, because every day I think everybody wants to become a much better engineer. So at the end, we try to do the things much better, right? So right now in our presentation layer, we are using this model view presenter pattern. Who of you guys know this pattern? Oh, not so. No, so. OK, I think the model view presenter pattern is perfect for Android apps. So because they couple the views from the business model really, really well. I want to explain you a little bit. So we have the view. Imagine that we have an activity or fragment, and then the user interacts. Imagine that the user marks a task as complete. Then this event is going to, the passive view, the view is going to call the presenter, is going to use the presenter, that the presenter is like the glue between the view and all the business model. So the presenter then will invoke the use case, and then once that we have the data will go to the presenter, and then the presenter, using a callback, will say to the view, hey, this is your data, you can update. And also, we are following clean architecture. Oh, you guys have heard about clean architecture? Uncle Bob? Oh, not so many. OK, well, we are following clean architecture. So our work in progress work is this. So we are having now, we have not 100%, but we have in the presentation layer, we follow the model presenter pattern. So right now, our activities, they are almost stupid. So they have just the UI, as it should be. I mean, as it should be, it depends. Because Google always shows, if you check the code, Google always shows that activity, they are like monsters, that even they have a business model, but it shouldn't be like that. I mean, for an app that you do in like 1 weekend, it's OK. But by a monster user by millions, it's not OK. So then we follow here in the presentation layer the model presenter pattern. Then we have our, now the core of the app is this, is the same sync module, the domain. But now, instead that before the sync was exposing an interface and the SDK another interface, now we have interactors. So it's an interface that the sync layer is exposing to the presentation layer, and then the presentation layer will invoke this interactor, these business use cases, and then we will do something. And then here also, the sync domain is exposing a repository interface that now, instead of having an SDK, we have a data module. No, not a data module, a data submodule, and also all the REST cache, REST WebSocket database, they will be standalone modules. So they will be like pure Java modules. So they won't have any Android dependency, and it's amazing because at the end they are managed by the repository, but we can change the future. Imagine that we want to implement a new cache, we could do it. We just replace this module, put another one, and that's all. The rest of the app is working like it will be the same. And yeah, and also, who of you likes loaders? I don't like loaders, and we have a lot of loaders. So now the app, we are moving to reactive extensions. Because at the end, I think Wunderlist probably is the perfect case for a reactive app. We have a WebSocket, we have real time. So we have things that they are coming through the WebSocket, and then we have to do something. We have to update the UI, we have to update our database model. So it's the perfect example to have observables that is emitting data. So yeah, right now we are moving to reactive extensions and to remove all these loader thingies, async tasks, and so on. And I think that's all. Questions? OK. I don't know. Where is the guy?
The question is how you deal with the deletions. So if you update the inserts or updates, it's OK for your model. But how you deal with the deletion of the objects? Like I deleted the task or subtask. How you synchronize it across the devices?
We have local IDs, and we have. Well, the question was that how we deal with the deletions of a model, no? So imagine that a mutation is coming, no, and then they delete the object, or we delete directly from our UI a task, no, for instance. Yeah. So then we have local IDs, and we have online IDs, no, and we deal with that. So we have our entire model is backed in the app, and then when we want to synchronize, we send this data, and then when the API model sends us the new data, and it's different than our model. Always the server, the backend, is like his opinion is the only one valid. So then we remove this data. Yeah, more or less.
You show that you have some kind of synchronized ticket that contains models for mutation on the data, but you just said that all decisions based on
The purpose? Yeah. What is a mutation? Or no?
No. You showed that your application has some kind of mutations model.
Yeah.
But you just said that all decisions, how data will be held, is based on a server decisions.
Mm-hmm.
So what's the difference between server and these models?
No, at the end, the mutation is just a data that is coming from the server, but that we didn't request. So the client can request data, and then we have our data, no? No, it's at least data that is coming, and then we can do something with this data or not. Maybe we can, because maybe imagine that the data is corrupt or is data that maybe the server was failing and it's sending us data that we don't want because this data is not for us. Then we discard this data. Yeah?
So all logic is on the server.
Yeah. Actually, the server is like the opinion of the server is like the decision is the main decision. So imagine that we have a task that it has a revision ID, imagine 3. And then the server sends us one with the same task, with the same ID, but with a revision ID of 5. Then we discard our task.
We have one more question from here because we are running out of time.
Okay.
Thank you. For
I will
speech.
be here.
Can
so
you describe the conflict resolving mechanism, please? If someone change, let's say, name of the task on one device and the second device.
is what I said. At the end, is the server is the decision of the server. So you have a shared list with your coworkers, no? And then one change the task, as you say, the name of the task. Then we receive this data with the new task.
In the same time, if it happens in
Ah.
one and the second device.
Always the one that is like more recent. Always, even if it's bad.
On the time.
Yeah.
And you sync time between devices, or you send it to the server and the server decides.
No, always the server. Always the server. We don't have anything like we don't talk with client A and client B. No.
So if you have a problem with the connection, those changes will be lost.
No, your changes, they are going to be in the app, and when we are available, when you have connection, then you are going to send the data. Yeah? I don't know if we have more time. But
Sorry guys, we don't have enough time for all questions, but you can find...
yeah, we'll be here the whole day and probably later, but not so late in the party because I have to take a flight early in the morning. So thank you.